Hello. Can you hear me all right? Cool. So I'm going to talk to you a bit about how we evolved our application architecture for Searchlight. Our code dates back to 2009 before we had easy access to any sort of nice front-end application development code. So it's certainly gone through quite a few iterations of kind of states of being, really. So this is kind of how we started off. We have JSPs that were just, server-side templates, and we had jQuery spaghetti on the client side, just kind of hooking into views that already existed, kind of twiddling things, setting things wherever. It got the job done. It wasn't very maintainable, and it was kind of hard to work with. First, I'll show you kind of what our app looks like, so you can kind of get a sense of how things work and the particular challenges we have and how we choose to address those. So basically, we just present a whole bunch of data to our customers to just all about where they stand in the what are called SERPs, but basically a Google result. So this is for a demo account of Bed Bath & Beyond. It's not their real account, but it is actual data that we've gone out and collected. So the primary focus of our app is that we have a bunch of reports of data, and everything that we have is a widget, and that means it can be added to a dashboard. Okay, so it works well here, and it has to also perform well kind of in isolation. So this is kind of the primary focus of a lot of our architectural decisions. The other reason for a lot of architectural decisions is just going to be kind of the iterative development. We have to make sure that we support all of our legacy code just fine. So we started off as jQuery spaghetti, and then about a year and a half ago, close to 2 years, we started migrating to Backbone. A lot of our code has been updated to be that, and now just about 4 months ago, we started moving to Marionette. So moving from jQuery to Backbone is kind of the standard talk that you get to hear about. But for moving from Backbone to Marionette, we decided to adopt it piece by piece because we couldn't just kind of throw it all in there at once. So this is kind of the core order of integration of Marionette pieces that I would go with. So Marionette provides the region, which is a good way. It's kind of like a managed DOM element. It takes care of all of your cleanup of all of your models and all of your listeners, just so that as soon as you get rid of the view inside the region, everything is wiped out. With our old Backbone style architecture, we had tons of memory leaks all over the place because we didn't have something like the convenient Marionette region. So I would start with the region because that will work well with Backbone views, and that's what we did, and it kind of just helped us encapsulate a lot of our logic and clean up a lot of our data that was just leaking. From there, you can go on to the item views, the collection views, and the layout views, kind of just building up out there so that you can kind of just get this nice, easy to integrate into path. And then on the side, tangentially, whenever you feel comfortable adding either radio or the application into it, you can kind of just add those once you've achieved a certain critical mass of like here are components that can easily interact with one another. So basically, if you're not familiar with the Marionette pieces, you just have the region kind of encapsulates everything. A layout view allows you to encapsulate a whole bunch of item views. So like, and so even you can just throw like a regular Backbone view into the mix, and that'll just interact just fine. And that's part of the core interaction of Backbone and Marionette. Marionette is just built directly on top of Backbone, and they integrate just fine. So we've finally arrived at a point where we can kind of just stop focusing on the hierarchy of the view, and we can kind of think about how is our data being persisted throughout the application, how do we interact with the data from page to page. And so what we've come up with for this is something that we call the shared context model. It's kind of our canonical source of truth throughout our entire application. Basically, it loads data from the page at time of its initialization. So we preload the important information onto the page in just a JSON script. And this kind of reads it out there, and that holds configuration information like what account is this, what keywords am I currently looking at on this page, all that sorts of things. And then we take this shared context model and we propagate changes to all of the other models, all of the models that we set it to be interested in. And so what this lets us do is it really gives you a nice way to get a handle on something that would traditionally be stored in some sort of global configuration object. And instead, you have it in a nice self-contained backbone model. You get all the benefits of the backbone model. You can listen for events. You can listen to changes. You can just send information back and forth kind of through there. In a way, it's a lot like an event bus, but in more of a data-oriented feel. So on our page, the shared context model communicates back and forth with the router. And so this allows us to just set something on the shared context model. The router will hear that, and it will just update the URL. So something that's handled by the shared context model on this page is we have the dates, for instance. So if you see up here, this is going to be referring to the compare TP right here, which is just how the time periods for this data that we're looking at. So I'm going to just change that. And so that updates the URL right there immediately using Backbone's router. And this is kind of just a really powerful feature of the router in general. Notice that we're not triggering any route events here. Just everything else is listening to the shared context model and responding appropriately. There are kind of two ways of handling routing in Backbone, and one of them is to always pass trigger true in the options, and this triggers the actual route event. And this is using your router to tell your app what to do. And then the other way is to just not, just to use the router to reflect the state of your application. And that's what the shared context model does. If you look at the source for Backbone router, it's not actually mentioned in any of the docs, but there's a comment saying that you almost never want to pass trigger true. And that's because what the Backbone is trying to go there, it's trying to say that you want to use it to reflect the state. So we have a bunch of other things that can reflect in the URL. Rank type is reflected up here. We just have two different ways of showing what kind of what your rank results are. So if we look at that, right. So things that would not be stored in the shared context model are things that are not specific or are exactly specific to something that's not the entire page. So for instance, this filter here applies only to this table. It has no hold over whatever happens in this images table. So the filters update on the shared context model, and on page load, the shared context model will propagate information to the filters. So everything works both ways. There's what happens at load and then what happens after load. So they communicate back and forth, basically. And the router also is used to set some parameters on the shared context model in addition to the initial page load. So the primary focus of our application is widgets. Adding them to dashboards lets you create all sorts of different views of your data that you wouldn't get in a page normally. So, for instance, if I were to just filter this, like let's say I'm interested in things that move from top 10 to top 3 rank positions. So this is search results that have improved, although none of these are mine. and I want to see just like what are the biggest movers there. I can add that. And then at the same time, I can see anything that maybe just kind of fell off. So yeah, anything from top 3 to top 10. So anything that kind of possibly went down, or in this case, it's just going to say that, hey, what you had in the top 3 is still in the top 3. But I'm going to add all that together. So on a page, a lot of things can communicate with the shared context model. On this page, there's rank type. There are dates, for instance. But on a workspace, all that we're going to see is that dates can communicate with it. So what we have to do is we have a distinct separation of what widgets listen to. So when we're dealing with the code, the widgets only ever interact with the widget model itself. And the shared context model propagates information to the widget model. So that the widget is what is the report that we are most concerned about. And the general page information flows down to the specific view itself. And that way, so general information flows to the view, the model itself, which is then the only thing that deals with the specific view. And the layers of encapsulation there are to prevent anyone from assuming that there is data on the page that you don't always have access to. So basically, this is kind of what it all looks like when put together. We have in between the model for the widget and the view itself, we have an adapter layer. And we use this to kind of set up a level of communication between, say, the data that you're interested for this view. So if it's a collection, the collection will listen to the model, and when the widget tears down, the collection will tear down. So it's just there to kind of separate concerns to take the data out of the view itself, which makes the views more reusable. So I just have some kind of pseudocode of how this would look. None of it kind of, can I make that bigger? Cool. It's kind of like, here's how it works. We have this not so great pattern called just create view. We have a static method on a view, which is a way of hooking the data for a view into it. The data that we almost always use gets hooked into there, but we leave that all out of the initialize of the view because it makes the view easier to test. It also enhances separation of concerns, although it's still in there as a static method, so it's not fully separated. So on a workspace, we're going to get a widget model. Otherwise, we're going to want to create one. And again, the widget model has everything that's going to be saved off to the database, reloaded on the workspace, and just kind of shares all of this data kind of to persist it. So we do the push changes. We push all changes from the shared context model to the widget model. And that means whenever the shared context model updates, the widget model will update with those exact same values. And that is, again, just there to separate the concerns. So we plug the data. We get our collection of whatever we care about. We feed that through an adapter, which will set up listeners. And then, in this case, it's going to fetch in response to any of those. So a lot of our reports are about if you change a parameter, that will correspond to an endpoint that has a different sort of filter on that data for you, and then it will just get it back. And so then that really just goes into a new view, which then can render, it can do whatever, and on destroy, it will tear down the widget model and collection, which is important to just make sure that you don't leak any memory. Yeah. So just a little bit of a sample of our router code. Sure. Is that good? do that again. Basically, we listen to a change, any change on the shared context model. We have a little bit of filtering based on like what parameters we actually want to update and reflect in the URL. And then we kind of just have to, we put it all together into the params, and we replace the current URL that we're dealing with, because we don't want to actually, if you go back, we don't want that to trigger a change to any of the filters you actually have. We want it to take you back to the page that you were on previously. So it's more of a bookmark style routing scheme. Just a bit more about what we used in our transition from our jQuery to Backbone and Marionette. We migrated from JSPs to handlebars on the client side. We used require.js, although in between we had a stage where we weren't using full require.js, so we had an adapter hooking it with a global object. We used backgrid, which is really awesome for making tables. For making backbone tables, you just give it a collection and it'll give you a row for each model. So this is a backgrid. Each row is just one of our sample models. It provides a lot of just like the auto refreshing of everything. Really handy. We unfortunately adopted it really early, and like it was version 0.1, and so it broke completely by version 0.3, and we just had to like retrofit a whole bunch of our code to kind of interacting with it in its new way. So we also use high charts for graphs. We don't have any graphs on the page. Moment. If you're dealing with time in JavaScript, does anyone use Java? No? No? That's good for everyone. Wow. Envy you. But yeah, it's very good for dealing with any sort of time manipulation, any sort of parsing. It's awesome. So if you deal with dates, use Moment. You'll be happier. We use promises everywhere, and so that's what we use. We use when as our promise polyfill. It also has a lot of good promise features that even if you're using something just for greenfield browsers, Chrome supports promises natively. You should still use a library like when or Q or anything, because you will get a lot of great features out of them. One of the things that when does for you that like natural Chrome promises don't do is that it will throw errors if your promise isn't even catching errors. So a lot of promises will fail silently, which means that if there's an error in your promise and you're not catching an error, it'll just, you don't know what happened. So when will actually fail loudly, and it will tell you that you have an unhandled error in your code. So I would recommend using that. Use a little library I developed called Backbone Horde. It lets us, all of our widgets kind of fetch their data in parallel when the workspace loads. No. I don't know what just happened there. Right. Okay. Right. So when this loads, all of these widgets are just going to fetch their data in parallel, and they can refer to the same data, and they might not. We don't have any sort of application container. Backbone kind of doesn't really want you to work that way. Using things. A little bit. That's how I want to eventually take it. Yeah. The question was, would I consider these services or microservices? And yeah, each one of these I think of as kind of its own self-contained application, especially on a workspace. But on a page, they need to interact with each other, which is where something like radio would come into play. You can trigger events, fire and forget if you want, and just kind of gets that global but constrained communication going for you. So on a workspace, a whole bunch of things can just fire in parallel. Horde will make it so that only one of those requests actually goes out, but every collection is still updated according to what it needs. And so in the future, plans for things that I want to kind of work into here are synchronously available data. We have a lot of configuration data that doesn't change. So we can just load it on the page once and get immediate access to it. And so that would kind of work in the same style of pre-populating data on the page in the JSON script, loading that in the collection, having access to it without having to do any fetching, without having to use any promises or events, and it would just be immediately available. More radio, as we're talking about, since everything's kind of a microservice. And in general, something that, again, Backbone doesn't want to really let you do, inversion of control / dependency injection. Other services out there, other things provide this. Ember does it, basically, Angular, but we need to kind of build it into a Backbone way.